Hello, my name is Lucas Eichmeier, and in this part of low-temperature solar thermal power systems, we're going to speak about the integration of solar collectors into bigger systems. Within this video, we're going to talk about pool heating systems, solar thermal systems for domestic hot water heating, and also for the heating of the houses. We're going to speak about solar district heating systems with actual seasonal storage, and as well, very briefly about solar air conditioning systems. I've already shown this picture in previous videos. We can use unglazed solar collectors for pool heating. This is a very simple system. We are using a very simple solar collector, the unglazed solar collector, which is able to heat up the pool whenever there's sun available. You're having a solar fraction of around 100%. So you're going to use the solar energy when it's available and do not use any other means in order to heat your pool. Another very simple and efficient system of integrating a solar collector into a bigger system is the Thermosyphon system. These kind of systems are widely used in regions without frost. If you look at how a Thermosyphon system works, you can see there's a solar collector at the bottom, which is connected to a hot water tank, which needs to be placed above the solar collector. As I said, it is a very simple, efficient, and also a cheap system where no electricity is needed in order to pump around the water. Water is basically or is simply circulated within the solar collector and the hot water tank by different densities of the water, by the buoyancy effect of water. We do not need a pump, therefore, and also no controller is needed. The disadvantages of these systems are that it is only applicable in regions without frost. We need to place the hot water tank above the solar collector, and the solar collector, of course, is outside the house, so the hot water tank is also placed outside of the house. This means you cannot use it in regions with frost, as the hot water tank would actually freeze. Additionally, some people would claim that it does not look very nice. It's not very aesthetic to have hundreds of thousands of Thermosyphon systems on top of houses. In the next video, we're going to speak about in more detail about how to actually calculate a Thermosyphon system. A more advanced system to actually produce hot water is the forced circulation system. It is a more complex system where we use a pump to circulate the water between the solar collector and the hot water tank. The system is, or we are also able in this system to use an auxiliary burner to heat up water when there's no solar radiation available. This system can now be used also in regions with frost, as the hot water tank can be placed wherever you want. You are using a pump to circulate the water anyways. An even more advanced system is the Combisystem. In this system, we're going to use the solar collector in order to heat hot water for domestic uses and also in order to heat the houses. And finally, we can combine many of these solar collectors on different houses to a very big central storage tank. Then we're speaking about solar district heating. This is applicable for entire housing estates and has the advantage that the surface of the hot water tank, with respect to its volume, is going to be smaller if you use one central hot water tank compared to many, many different hot water tanks in each individual house. Disadvantages of the systems include, of course, higher losses within the piping and a higher initial investment. And now, if we look at when do we actually need solar heat? Usually we want to heat the houses during winter, and we have lots of solar radiation available in summer. In order to compensate for this mismatch between the demand in winter and the availability of solar radiation in summer, you can build a seasonal hot water storage. It can be seen here in the picture. It's a very big tank where you can store hot water over a couple of months. The main disadvantage of this system is quite obvious. The tank is relatively big and you need a very big initial investment. Finally, you can also use solar collectors to provide low temperature, low grade heat in order to create solar air conditioning. These processes usually involve absorption processes which use the low grade solar heat to convert it to cold. Thank you very much. This was low temperature solar thermal power systems, where we spoke about the integration of solar collectors into bigger systems. In the next video, the last video of this series, we're going to talk about some guidelines, some help for how to calculate thermosyphon systems or solar collectors in general.